All right, good evening, good morning, etc. Welcome to the second session with the Internet of Things Capstone project. We're along for, as I said, our second meeting, so let's move that along. Just a reminder again that all of these meetings will be recorded. We're going to post them to YouTube so you can have a review of these if you missed them, or listen again if there's something you want to hear. And you will have access to all of the videos via a YouTube channel, which is up here. The link is there. The link's also on edX, so you can just click on that and have a look at the channel. Tonight we want to try and get towards the aim of these sessions, and that is to have you, the students, leading the discussion. We don't want to be talking at you. We want to find out what you're up to, let other people know what you're up to, and perhaps get a little bit of collaboration going there. Tonight we'll quickly run through the requirements for the next couple of weeks and answer any questions on that. We've had quite a few emails coming through on the Capstone, IoT Capstone email address. I think we've answered them all now. If not, can you please let us know, remind us, and we will put them back at the top of the list. Also, we're hoping that everyone has joined the team and have started a discussion within the teams on what they're planning to do, and sort of trying to meet the others, get some general groups together, people with some common interests in common areas for their proposed solution. And one of the things we'd like you to think about doing is finding a name for your device or your solution. That's going to help, one, in the communication. It gives it some personality of its own. And when you're discussing it, rather than saying my IoT device that is going to fix the problem of tracking where snails are in my garden, you can refer to it by something a little bit more imaginative, a little bit more marketable, such as snail tracker or whatever you decide to call your device. Someone's actually come up with a really good name already, which is IoHorse, which I thought was quite neat. But it is nice to have a name, something you can put to your design and use it in the descriptions. Okay, so what we're going to be doing this week and next week is generally starting on the Canvanizer. Canvanizer is a very handy method of getting your ideas down on paper, being able to brainstorm ideas, share your ideas with other people, and can be used in part of the, or quite often used in the part of the development cycle. What we need to have is a definition of the problem. So that's picking the top 3 problems your IoT idea will address. It's important that you keep a very narrow focus on the problem we're trying to solve, not necessarily the features that are going to be within your device, but the actual solution you're working on. Your feature list can be quite extensive, and it's good if it's extensive. When you've got an extensive list, it's one of the issues you have to do is look at how you're going to implement these features. By keeping the problem definition fairly tight, you can lock your feature sets into basically 3 segments. So the first segment you would have in your feature set that address a problem is the items that are going to, as a minimum, solve the problems you've stated. Right? So this is the things you have to make your device a success. It's the items that if you don't have this particular set of features, the device will not sell or won't perform the function that it's designed to do. So it's absolutely critical that you have this set of features included in your design. Excuse me. The second set is the things that would be nice. So things that would actually add some value to your product. They're possible to be implemented. If all was going well, you would implement them in there. So they're the desirable things that would be nice to have and would increase the saleability or the marketability of your product. And the final set is those that, in a perfect world, if everything went the way you like, if all of the technology was available, this is what you would add in as the final set of features. This is handy for building a roadmap. So what is the device going to be like in the future? What are you aiming to get it to in future iterations? But they may not be things that are either feasible because of time constraints or technology constraints or a range of other things, but they would be nice to have in there at some point. Now, when you've divided your requirements into these sections, a nice way of working on these is to start from the easiest first. So I'll go back to that horse monitoring example. It's to look at the health of a horse. So a few of the things that you need to do is you want to look at the body temperature of the horse, the heart rate, the breathing, and the really complex one, I hope he doesn't mind me saying this, is you need to be able to detect the colour of the horse's mucus. Now, for this device to be successful, we would say, for example, we need to be able to measure the temperature and the heart rate. It'd be nice to know the breathing, but that's a bit more difficult to implement. And ideally, we would look at the colour identification. But that's going to be rather difficult to implement, particularly if it's going to be in situ on the horse. So what we would do is we would have that range of features. Our problem statement would be we want to monitor the health of the horse. So to do this, if we just look at the temperature and we implement that first, it's relatively easy to do. So we can reach our first milestone fairly easily. Once we've done that, then we can work on the next most difficult task, which is the breathing. And if that all works and everything's together and running quite well, then we would look at the heart rate, and that is our mid set of features. At some point in the future, because of the difficulty in doing the mounting on the horse and the colour identification is more difficult, we would have a roadmap leading to this eventual design that would include the monitoring of the colour of horses' mucus. Lovely thing to be looking at. But at least this way we have a way to get a product to market. We have a usable device that solves the main problem that we have identified, and we have a roadmap to head for future iterations. The next part would be the customer segments. So we've got to know who we're going to pitch our idea at. If we go back to our snail tracking, we would use this device and aim it at home gardeners, for example, who want to grow their own organic produce. So we have a very clear idea of who we are aiming this device at. It might not be suitable for, say, professional market gardeners because all they want to do is eradicate the snails. They're not really interested in just keeping the crops safe. They want to make sure that the pests don't come back. So make sure you've got a very clear idea of what or who will experience the problems you've identified and what market you're going to be going for with your solution. You need a unique value proposition. And this is the single compelling message about why your IoT is different and worth buying. If we think again of our snail tracker, it may be that there are ways to control snails. We can put out baits and traps and other things which will kill the snail. But we may have some objection to the wanton destruction on the snail population. So our unique selling proposition, or unique value proposition, is the fact that we can control the damage the snails do to our garden without actually killing snails. So we'll know where the snails are, we can go and pick them up, remove them and give them to somebody else as their problem. So that's something that would be unique. We're not just killing the snails, we're not using poisons, we're being organic, so it has a unique value proposition. I've already mentioned the solution, the top three features of your IoT. This is to go into the Canvanizer sheet that you're doing, but I really don't see an issue if you want to do more than 3 features. Just make sure that you segment them out as I've described so that you have a good idea of what is absolutely necessary and then the other features which can be done further down the track. You need to identify, and we'll go into this in a great deal more detail further on in the course, is the channels. How are we going to market this? How are we going to find the people that need our product? Our snail tracker, we could look at the gardening websites and put things out on those particular sites. We could join Facebook groups for gardeners, but we have to identify how we can get word of our device out to other people that would be interested in buying it. Again, we'll be going into this in further detail later, but we need to have a look at the cost structure. The cost structure is very variable. We've got to look at several aspects. We need to recover the money that we put in to develop the system. That's all of your time, the resources you bought, the prototypes that you built, and recover that cost across the entire production cycle. So to be able to work out these costs, you need to know roughly how many of these devices you are going to sell, so that you can divide your development cost across there, which comes from the channels and the unique value proposition. We need to know what everyone else is selling their product for. So if we want to compete, we have to be somewhere in the ballpark of the competition's selling price, unless we are doing something that is so much better than theirs, and then we can go above their price. Or if we are producing something very, very cheaply, we can undercut the competition's price. The costing, unless it's for a philanthropic purpose, generally is made to maximize your return on investment. So even if you're producing something for 20 cents and nobody else can match what you're doing for this 20-cent device, the closest competitor is selling it for $100 a piece, you would probably come in at $90 anyway, just to maximize the return on investment. We have to look at the revenue streams, both for funding and the revenue sources to build your IoT device. And again, we'll look at that in more detail later on. And another key thing that we will need to have done on the Canvanizer is to set up your metrics. These are the ways we measure whether the device is whether our project is going to be successful or not. Without milestones, it's very easy to get lost, to go off schedule, to lose track of what you're doing. So if we go back to that horse example, our metrics may be we can successfully read the temperature of a horse and report that to the dashboard we've created to monitor the temperature of the horse. So that would be our milestone 1. Our next milestone would be being able to measure the breathing rate of the horse. And when we achieve that, we can mark that milestone off. And so on through the process. There's the unfair advantage part as well. If we look at our snail example, our unfair advantage would be that we're very humanitarian and we're not actually killing the snails, which nobody else is doing because the rest of the solutions are based on baits. So generally, these are the sort of things we need to cover within the Canvanizer that has to be submitted within the next 2 weeks. So I hope people have started to have a look at this. You've been through it before in the IoT1, so it shouldn't be anything particularly new. That's the example we've used before with the snore stop. It's a very brief one. I'd like to ask permission from the gentleman who's doing the horse monitoring to show his at our next session, just to give you an idea. But also, with the submission of the Canvanizer assignment, you have to go off and mark 2 other people's submissions. Now, while you're marking these 2, try to look at it as more of a learning process on your part, not just covering the requirements. By going in and looking at the Canvanizers that other people have done, you're going to get a very good insight into a very broad range of skill sets. We've got a vast array of people within the course with very different skill sets. And I mentioned this previously, I think. We've got people who are very technical, we have people who are business orientated, we have people who haven't done anything like this before. And each of these groups of people would have a very interesting perspective on how to go about the design process. And by looking at theirs, you can gather some really interesting, worthwhile ideas. So even though you only have to go in and assess 2 of these Canvanizers, I would strongly suggest that you have a look at a few more and try and gather some ideas and see how other people have approached their problems. And that will be quite beneficial in how you go about your design process. Okay, if you do find something that's particularly interesting, make a note of who it is, contact them on the discussion boards or through the teams, and get into a bit of a discussion on why they did things the way they did. That's also true of the constructive negative comments. If you find something you think is wrong or could be done in a different way or could save time, effort, resources, let the other person know. It's always nice to know if there's a better way of doing things. All right. Finally, what we would like you to have done next week, is to have joined a topic team. I assume you all have. posted your idea in the discussion board, and provide some feedback to your fellow team members on what they're proposing. Again, this is a great learning process. You'll be able to pick up lots of interesting things from what they're doing. You've obviously decided which web conference group you'd like to join because you're here. But I will mention again the YouTube videos. If you have a few moments spare, you can run through some of the other sessions just to see if anything interesting came up. And this will become more useful later on as people start to become a little bit happier and freer with the expression of their ideas, which is what we really want to try and develop here. You should have watched the product development videos and use these to start thinking about the business plan for your device or idea. These videos are there as a support. They're not really as part of the assessment or part of the requirements of the course. Well, that's not quite true. They are part of the requirement. We want you to watch them. Our main focus is on this development process. So these seminars are probably the most important part of the IoT6 project. So you should be working on populating your Canvanizer template and submitting it. This will count 10% towards your overall mark. So it is a significant amount, but more importantly, it's a way of getting your ideas down on paper, being able to share these with other people and get some feedback on what people think of your particular idea and how you're approaching it. I think that's really all I wanted to go through. If anyone has not had an answer to their email, as I said, please let us know. But what I'd like to do is now ask people, if they have questions, to either put their hand up in the chat or type a message on the chat line. And while we're doing that, I'll just get out of this and I'll just show you the YouTube channel. So keep an eye on that. Can you see the YouTube channel there?
There it is.
Yep. Okay, so we're putting all the seminars up. You can have a look at some of the other sessions, for example, and it might be quite interesting to jump into Group C or D, which is the industrial and other group, and just see what they're up to as well. Have we got any questions?
None at the moment. So if anyone has a question, just hover your mouse over the participants list and find your name, and it should let you click the hand symbol to put your hand up, or type in the chat window if you're not getting a good enough connection for that. And I can read out a private message, or you can type to everybody.
Okay. While we're waiting, a couple of things we can do. We had some questions come up in the first seminar this morning about building prototypes. One thing you can start looking at now is what platform you want to build it on. Our favourites are Arduinos or, here we go, Arduinos or Raspberry Pis, but it really doesn't matter what platform you use. We tend to use off-the-shelf equipment because it's readily available, it's usually fairly cheap, and you can look at fine-tuning that and reducing size, power consumption, cost, etc. once you've made sure your prototype is actually going to work. Josh, someone had a question there.
Yes, Tech AXA has a question. How do you anticipate carrying out the user testing?
Well, that very much depends on who your target audience is. There's a lot of different ways we can do this. In many cases, it's really an issue of identifying who they are and trying to locate someone in that environment. Can you let us know what topic or what field your project's going to be in? Because that actually impacts quite dramatically on how we can test.
Yeah, so
if you're doing
talking from primarily a user design perspective, it says. I'm not sure of the field, I can't remember from last week.
If you're creating, say, a user interface, probably this group would be a wonderful test audience. You know, get people to try it out. If you set up a web interface or even have pictures of how you envisage your user interface to be, that would be a good thing to share amongst people here.
So yes, an asthma IoT device.
So it's an IoT device in...
Asthma, for asthma.
Ah, right. Okay, so if you know anyone with asthma, you could try it on there, but you can also try, if you're measuring breathing or pollen levels, you can test that on yourself with normal breathing if you don't have asthma, or if you do have asthma, well, it's ideal you can test it on yourself. However, be very careful about going back again to our privacy and security issues. If you start to involve people outside of your immediate family or friends, you may have some issues on privacy and ethics to do with research on human people. When you're getting to that point, just drop us a line. We'll see whether it's going to cross the line on that, whether you need to do anything else. But generally, we would suggest that you just test it on yourself for the time being. And that's a good way to test basically any sort of design, is make sure it works for you, get some friends or associates to look at it as well, get this group to have a look. I'll also, actually there was another question, I'll mention 3D printing in a sec.
There's a question as well from Euros, Denik. What's the most efficient and comprehensive way to see if our solution is already patented?
Believe it or not, a Google search.
Okay.
That usually does show up most things, but once you search on patent, you'll find that there are sites that will check things for you. So I just did a quick one on patent. No, I spelled it wrong. Never trust my typing. Okay, so here we go. You can go to IP Australia. If you're in Australia, searching patents, IP Australia, it'll probably come up with a local one for you. Google Patents is a good one. Still seeing this? Yep, I hope so. So on this we can go there we go. And we have some monitoring dates and other things for the horse. All right, so it's not that hard to do a quick search, but also if you do a commercial search is another thing you should be doing as well. And I believe we run through some of this when we look at the intellectual property part later in the course.
Okay, so we've got a question from Justin to everyone. Is there an expectation that we will have a working prototype of our system by the end of the course?
Absolutely not. No. It would be very nice. I would hope we get some progress towards having a working prototype. But no, if you don't have a working prototype, it doesn't mean you're going to fail a course. The idea of this course is to get you in a position where you can explain your design. You know technically whether it's feasible or not, and you have sufficient knowledge to communicate with people in the areas which are outside your expertise. So if you're an electronics technician, it'll be great. You'll be able to build most of the prototype. You can test it out, but you may not have everything you need to do the business plan, the costing, the prototyping. But you would be in a position to be able to communicate with the experts in that field on what the requirements would be. Going from the other side, if you're not a technical person, you should have your business plan all done. You should know where you're heading. You know what your market is. And you'll have the ability to communicate with engineers, software developers, etc., to be able to get your prototype built. So having a working prototype at the end is always very nice, but it's not an absolute requirement. That really depends on your own skill set and where you feel yourself heading.
We've got another question from Vijay Kumar there. He says, I'm planning a platform solution with a physical product for the basic solution and the concept for each of the system solutions, and one of these using blockchain. So what's your question, Vijay Kumar? Just come back. We'll come back to that. But for anyone who has got a question, you're welcome to put your hand up and unmute your microphone. Don't be shy. You can also do it over the microphone rather than just the chat if you like.
There we go, Anthony.
Yes. Sorry, Anthony, you've got your hand up. Hello, Anthony.
Oh,
he's typed it in. Yeah, it didn't work, obviously. Audio. How much of the design process / business case background information needs to be presented, or are you just looking for the final bid level proposal or summary?
Okay. From a business perspective, it depends again on your focus. If you're focusing on the business aspect, we would expect a reasonably detailed proposal, costing, market research. If you're concentrating on the technical aspect, well, we won't expect quite as much there. I will be putting up a template of sorts for the final report, so it'll give you an idea of what's expected, and there'll be some comments in there on what sort of detail we would like in there. It really is an individual effort, so what somebody may consider sufficient or insufficient in, say, the business case, for others that may actually be sufficient because it's balanced out by the technical. We really want to see that there's an understanding of the process, the design process, and implementation where that's possible, or the business plan, or perhaps both for some people who want to get that far. Not sure that answers it, but it'll be a lot clearer when we've got the template posted, which I think is coming up in about week 5.
Okay, just a reminder, we also do have Nazanin, Siavash and Valerie here if anyone has any more specific questions in their areas, so networking or coding or embedded systems.
I think Sana.
Hi, Sana? Are you there?
Hello, are you hearing me?
Yes, we've got you.
Okay, now I'm working about my idea. It's about motion tracking and for head motion tracking for children with cerebral palsy. And I'm working also for a prototype. I buy all the equipment I require, but I now have a problem about the sensor, IMU sensor itself. I know I don't have so much information about it. It's the first time I use it. I search in the internet, and there is few resources explain how I can connect them with the microcontroller and how can I read the data, how can I analyze the data. So my question is there any book resources will help me to understand how this sensor works?
I think Siavash is the best one to answer that. He's our IMU expert, and no doubt has some resources or can help you out with that. So, Siavash?
Sure. So just a quick question, Sana. Last time I spoke to you, you were looking into getting an Arduino development board that had an IMU embedded on the development board. Did you end up getting that, or did you end up getting a separate IMU and a separate Arduino?
No, I buy a separate IMU and Arduino and Pro Mini as you suggested, and Bluetooth low energy and that stuff. But I told you I have some issue with understanding this sensor, so I can program it to read the data and to identify where is the problem in head control for CP children.
Okay, I see. So what I would suggest, just to begin with, to make things simpler, if you're interested in building the prototype, just start by a very simple, just getting the IMU to work, connect that to the Arduino, and don't worry about the Bluetooth module just yet. And you can just display the information on your serial monitor rather than sending it through Bluetooth. You can just see what you're reading directly from the IMU. And I'll send you a couple of more. I think I sent you a couple of links on a couple of sample example codes of getting the IMU to work with Arduino. I'll send you a couple more. And,
I prefer a book. book is very helpful to me. I want to understand everything about it because I want to work with it not only for the course. I want to do a research. I want to have a data and analysis these data.
Ian, do you think the book you sent beta might be helpful to her?
It might be.
Filtering in it, so.
Yeah, it's actually more for positioning, that book, but it will actually give the accelerometer use, the Kalman filtering. So, yeah, share that with her, no problem at all. There we go. So there's lots of little things like this around. I think am I still sharing the screen?
And also, just keep in your mind, I'm absolutely beginner with IMU sensor. I have no idea about it. I just Google it and find and watch some videos, but not very. I want to understand everything about it.
No, that's why I'm suggesting like taking things step by step. So if you start by first step, get the information. Just the very first thing, just try to read the IMU sensor. Okay, now that you've read it, you know what sort of information you're getting from the accelerometer, what sort of information you're getting from the gyroscope. Then you can build on your knowledge. Then now look into, okay, what can you get? What can this data be converted into? How can you use acceleration or angular velocity to get the movement you're looking into? I think like if you once you get that information, and the reason I'm suggesting article because personally when I see a large book, it might become a bit overwhelming. But if you think things step by step and get the hardware to work first, then maybe there could be a different article, different paper, different video that focuses on actually the conversion and more understanding more the orientation and actually getting information from the sensors. It might be a bit easier for you to get a more in-depth understanding of it rather than just reading lots of different information about the IMU and not knowing where to focus, I think, your project.
I'll just put a link into a nice guide on what IMUs are and what they do and what they actually measure. So it's probably a good place to have a look. Then next week, at our next meeting or via email, we can talk about how do you sample this, what does the acceleration actually mean, what does the gyro actually measure. But have a read of that article. It's probably going to help you out understanding what they do and the kind of readings you will be getting from them.
And I'll also send you, there's a book that actually my wife's been reading, and a couple of more helpful links in more of the nitty-gritty things of getting the Arduino and the IMU to work together. Just to make sure, did you end up getting MPU 9250 for the IMU?
Yes.
Okay. Yes. All right, sure.
Okay. And we can do more of that.
Yeah. We've got a question from Mazen as well. I think he's got a microphone. If you'd like to ask that, Mazen.
Hello.
Hello, yes.
Hello. Yep.
Hello, everyone. How are you? Yes, I didn't participate in the previous session, the last fortnight, so I'd like to introduce myself. I'm Mazen Atom. I'm an electronics and telecommunication engineer. Originally from Sudan, but now I'm working and residing in Saudi Arabia. My IoT idea is about controlling the diet system of human being. The scenario of my IoT idea is about implanting a sensor inside the stomach of the patient and getting information about food intake and food type, and sending this information to a wearable device, internet-connected wearable device, also to be connected with an actuator to control the patient appetite. So I think I have sent a YouTube video and I have received a comment from Professor Ian Murray. And you asked me, Professor Ian Murray, to look for hydration levels. How can we measure hydration levels? So I looked around to have some information how to control the hydration levels. I think we can measure the conductivity. We should have a conductivity sensor inside the stomach to measure the conductivity of the contents of the food and measure if it's water or it's a food, solid wood. Combining all this information with the sweet rate sensor to be wearable, and also information about the activity of the patient. So combining all this information and calculating it, we can come up with how much this patient drank fluid or water, and how much he consumed consumed the water. So we can come up with the hydration levels. Another method, I asked medical practitioners about how can we measure the hydration levels. They suggested to implant a sensor inside the bladder to sense the creatinine and urea and sodium levels. From this information, we can come up with the hydration level as they were noticed. So this is my idea in general, and I will be happy to receive your feedbacks and guiding me to let my idea come into the light.
Okay, it's certainly an interesting concept. I'm a little, I wouldn't say concerned, but interested in knowing how you could actually get this into the stomach and keep it at the stomach level, because things tend to be passed through. Did you have any idea on that, and how are you going to encapsulate it so it's safe for the person to actually swallow, or would it be surgically implanted? What are your plans on that front?
Actually, I look around and I searched the web, and I found that MIT has developed a solution of ingestive sensor. So this ingesting sensor may last for 1 month inside the stomach, and then it will get out. Another solution, as I said, through not a surgical operation, but by implanting it through a microscope. I'm not sure about the name of the equipment that equipment that will be inserted through the mouth. Going down.
Endoscopy.
Yes.
An endoscopy.
Endoscopy. Yes, exactly.
Yep. Okay.
Yeah. Then
you'll have some issues with the prototyping of this, of course, but it brings me to another subject we should try to be aware of. When prototyping, sometimes things aren't easy to prototype, or in the case of this particular project, it's going to be hard to find anyone to volunteer to swallow a Raspberry Pi. So what we can do is we simulate the sensors rather than actually use a real sensor. More common case where we do this is a case such as Josh worked on a while ago, where we were measuring water quality, and to measure the oxygen level in dams and ponds, the device was really, really expensive. So rather than go out and spend a large sum of money on a particular sensor, you can just create a pseudo sensor in the form of, say, Arduino Nano, which is only a couple of dollars, and you have that small microcomputer generate the kind of readings you would expect from the sensor, so that you can test the rest of the system without actually having this expensive or difficult sensor physically available. So in the case of the oxygen level, it would generate numbers on the analog scale from, say, 0 to 5 volts, which are randomized, but within the range we would expect of normal oxygenization in a dam. So that's a nice, easy way of overcoming the inability to get a particular sensor, or the very high cost of the sensor, if you just want to check to see if your system is working. And for that stomach one, that would probably be a good way to do the initial testing anyway. After that, you can build a artificial stomach with the right acid levels, etc.
Mm-hmm.
If I may give a quick feedback as well, Ian. So I was just thinking, one of the things that concerns it a bit about this project is, so you're thinking of it as a dietary help sort of a solution, and as Ian said, there's kind of a weirdness, but then you have to how you're going to put a sensor in. Maybe the project would become more attractive if instead of looking at dietary, let's say you're looking for a specific kind of stomach cancer or something like that, then it becomes a bit more crucial. And then say if there are procedures that people have to go through when they have to be constantly monitored, if instead of having those intrusive procedures, then you're just reading the same information with a small sensor, then rather than having to say give out constant blood tests or things like that, it might become a bit more, I guess, just thinking of it commercially, it might become a bit more interesting rather than it being a dietary reason. You might not find the right audience who would be willing to kind of go through advanced testing it just for dietary reasons. Just something I thought of off the top of my head.
Thank you so much. I realize it.
Okay, we've got a couple of hands up there, Josh, I think.
Yes, we've got a question from Ahmed, who's been patiently waiting with his hand up there. Hello, Ahmed.
Hi.
Yes.
Hello.
I can hear you.
Can you guys hear me?
Yes.
Okay. So my question is, does my solution for the scope of this course, does it need to be developed from first principles? What if there is a company in China that is doing something similar and maybe I want to use their hardware and then maybe work with my own platform, so on, maybe add some other ideas to the hardware instead of developing it from first principles?
Very good question. I would say never reinvent the wheel if you don't have to. So if there's something that does part of what you want to do, or something that would do the job that you want to do but is actually used in a completely different environment, go for it, use it. That's reimagining the existing products, and that's a very good thing to be able to do, and it'll also reduce your development and production costs dramatically. So yes, if there's something out there that's already doing something similar that you want to extend it, you definitely go ahead and use it.
Okay, thank you.
Anthony still has his hand up.
Did you have another question, Anthony, or was that up from before, possibly? There's also another question from Sana in the chat window asking about the best simulation program for such an idea, I presume referring to her own.
Yeah, it's a good question. I'm not 100% certain on simulation with IMUs. The problem with certain sensors like IMUs is they're very hard to actually simulate. I would probably be looking more at capturing the IMU data, storing it, and then processing it using some mathematical package similar to MATLAB, but there is a free version of MATLAB available.
She was referring to the stomach sensor idea of Mazin's.
The simulator, sorry.
We were discussing at the time when she was asking, actually.
Right.
Yeah.
Okay, for the stomach sensor idea, again, it's a similar sort of thing when you're interacting with this sort of, there's no real simulator available, but you could simulate the stomach by using a glass dish with the right acid mix and use that mixture to get readings on either pH or opacity for the amount of food that's in there, the conductivity, and the other measurements. So you would do it in a fake stomach, if you like. But simulating it in a software package, probably difficult.
Vijay Kumar has explained his earlier question a little more. So it's regarding his platform solution for smart crops. Is it okay to have a platform solution with a physical product for the basic solution and the concept for each of the system solutions using blockchain along with IoT? So you can see that in the chat window there.
It's certain what you're asking there. A platform solution with a physical product for basic solution. Yeah, if you're talking about having a physical sensor network and a platform behind it, that really is the ideal answer to all of the solutions we'd like to see. IoT is more than just having a sensor. It's more than just having big data and lots of data to play with. It's that communication between where you're collecting the data, gathering the data, making some sense from that data, and then it interacting with the real world without human intervention. And that's the strength of the IoT. It's taking humans out of the mundane part of any measurement or action and just giving them the information they need to make decisions. So if things don't require a decision, water tank is empty, I need to fill it up, that's not really something a human should really need to be involved in. However, when we've got other things which require a decision to make, should I add water or shouldn't I add water, that should be communicated to the human to make that decision. They don't really need to know what the volume of water flow is or what the quality of the water is perhaps, and lots of other details, but they need to be able to make those decisions on abstract data. I'm not sure if that answers your question, but let's know if it doesn't. The blockchain bit, why would you want to use blockchain? I always have problems with blockchain. Blockchain has been around in a different sort of form for a very, very long time. It may have some purposes, but it's a bit of a buzzword at the moment. I think you really need to think why you'd want to use blockchain. Do you need to keep it secure? Does it need to be a distributed system? And if so, does it really require blockchain? I may be wrong in your particular scenario. I think Val might be able to add something on using blockchain, but to me, it's a little overrated at this point. Anyone else?
Hello.
Yep.
Thanks, Anthony here. Just a follow-up question to before. If we have a solution that is both an IoT product that's effectively standalone, but also will integrate with a cloud-based data gathering, analytics, and a social platform, for the Canvanizer, should we be focusing on the full end-to-end solution, or should we focus on that one standalone product in a little bit more detail?
I would be looking at the overall, but with the emphasis on your standalone system, because having a description of the standalone system on its own may not make full sense, and you may miss some of the possibilities that could be implemented within it. So I'd be fairly broad, but again, concentrate on the bit you'll be doing. So you need to know the context you're doing things in.
Okay, thanks.
Okay.
Any more questions?
We've got a few minutes left. One of the other things I'll mention came up from one of the other sessions is someone was very concerned about the cost of producing the physical device. I think I'm talking about using or producing in injection molding. And if you do injection molding, the die cost to be able to start the production run can be $20,000, $30,000, $40,000 just for the setup cost. Something that's really worth thinking about in your prototyping is using 3D printers. There's lots of places around that will do 3D printing for you if you don't have one yourself. It's very, very cheap to do. And the nice thing about this additive manufacturing process is you can produce half a dozen or 10 or 20 of these parts for a reasonably low cost, a fairly high time cost, but a fairly low material cost. Try them out. If they don't work, you haven't lost that $40,000 on the tooling. So it's something that should be considered if you are building a physical housing or a physical actuator. 3D printing is a really, really nice way to go. We've got lots of 3D printers ourselves, so we use them a fair bit. And as I said, generally libraries or other commercial providers will print things for you at a fairly low cost. And you can do all the design yourself on free packages like SketchUp. So it's something worth bearing in mind if you're heading down that path. I should actually put some pictures up of one we've just finished, which is a tremor dampening for people with wrist tremor. So if their hand, like in Parkinson's, tends to move a lot, we've 3D scanned a person's arm, then used that to print a 3D orthotic to wrap around the wrist and the hand and attached inertial measurement units on it and a motor to counteract the rapid movement. And the material cost of printing that was, I think, about 50 cents. The time cost was huge, but material cost was very low. I'll try and post a picture of that on the, or a video of that on the YouTube channel.
I'm not sure if Ahmed has his another question to add, or the hand is still up, possibly. Yes, yeah, yes, he was waiting. Now typed. Sorry, what is the exact name of the trimmer thing? I'm not sure. Trimmer. Can you explain if you've got your microphone, possibly, Ahmed?
Sorry, I just want to know what's the name of the thing Ian was saying now to reduce hand shaking.
Oh, Tremor. It doesn't have a name. It's just a research project we're working on at Curtin.
Oh, okay.
Yeah. So we haven't come up with a name. One of my French exchange students is over here for a few months. Ah, right. The blockchain makes perfect sense then. Yes, from BJ. You've struck on one of the things which is, I think, a good use for blockchain, and that is assume the tracking of the produce from pasture to table. And yes, that's a very good application for blockchain, being able to track things securely through a distributed system. So yeah, go for it, I think.
For anyone who's listening to the recording, Vijay Kumar was just explaining the blockchain is for organic and fair trade input crops across the supply chain.
Anything like that, where you're trying to track things or trade things securely, that is actually a good use for blockchain. We've done a few projects using blockchain accounting for the sharing of microgrid power generation. So we've got a group of houses, huts, villages that are generating power and storing that energy somehow, batteries or one of the other methods such as water storage. You use blockchain to do the accounting for it, so you can track who's using the power, who's generating the power, and it's actually quite good for that. So any of those trading examples is worth having a look at. All right, well, we've only got a couple of minutes left. I don't mind if anyone's got any other questions, please yell out now or forever hold your peace until next fortnight. Don't forget, if you do have questions, feel free to email us. If it's something we can't sort out via email, I'll send back my Skype contact details and we can have a bit of a chat separately. I do have limited time, so I can't do that too much, but I'm happy to do it when we're stuck, try to sort something out over email. Thank you very much, everyone, for coming along. We look forward to seeing you in a couple of weeks and looking at your Canvanizer submissions fairly shortly. All right, recording.
Thank you.
Thanks, Alex.
Thank you.
Thank you. Thank you.
Coming along. All right, I'll get
Thank
that
you.
coming up very soon. Bye, yeah.
Thank you.